So now I think we started the recording. So again, when we talk about modeling, actually we are talking about two important items in modeling. We're talking about 2D modeling and 3D modeling, okay? When we say 2D modeling, we're talking about something called technical engineering drawing, okay? Using technical engineering drawing, we are dealing with working drawing, which is related to single product or single components drawing and details. So if you want to develop something like a blueprint or a chop drawing, okay, for a single component, this is called a working drawing. And we have another type of technical engineering drawings, which is assembly drawings. So they're a little bit different than each other. I'm talking about working and assembly drawings, okay? Each of them has some, let's say, characteristics and some contents. Like an assembly drawing, we may have something like boom, bill of material table, or we take a cross section from the mid plane of the assembly to show how the components are positioned together and each other, the positioning of each component, okay? And for the working drawing, we have all details for a single part or a single component. So we put all dimensions, we put all GD&T. I'm not sure if you're familiar with GD&T or not. It's geometrical dimensioning and tolerances. So you put everything in the working drawing to illustrate every single detail to the manufacturer of this component. So it's some sort of a contract between the designer and the manufacturer. I'm talking about the working drawing of each component, okay? So inside each working drawing, okay, you have to put everything as I said, okay? Because you have to avoid any questions as a designer to be asked by the manufacturer. This is the working drawing, okay? When we talk about 3D modeling, as we can see here in this model, this is like a assembly drawing or assembly model for something like an engine, something like that, okay? We're talking about something different. We're talking about 3D models. Actually, 3D models has different types. In 3D modeling, we may talk about something called wireframe modeling, surface modeling, and solid modeling. So the one we have here is called solid modeling, okay? Because it's a solid component. You can imagine everything and imagine the characteristics of this object or this model here. But actually, for the wireframe modeling, it's ambiguous. It's just like 3D lines in the space, okay? For the surface modeling, it gives you something like a shell or a thickness or something like outer profile of any object. It doesn't matter about the inner details of any component. This is for the surface modeling, okay? So let's move further here. When we talk about analysis, actually we have different types of analyses here. We have something called finite element analysis, okay? And we have something called CFD, which is computational fluid dynamics, okay? These are considered different types of analyses used in the product development or product design process, okay? So again, as we said, the slogan of SolidWorks is let's go design. The second slide here, okay? So design, as I said, is doing something called a model and then do analysis for this model, okay? This is the slogan of SolidWorks. So here, as we said before, these are the different types of analysis: finite element analysis and CFD, which is computational fluid dynamics. Actually, for finite element analysis, you are testing the real environment of the component or the assembly you are developing. I mean, you may apply some loads. Let's say the different types of loads may be pressure, force, whatever, stress, something like that, and then you see the behavior of the material and this load on the geometry, on the model you developed, okay? You see that if you apply this load in specific areas in this component, how it will look like, how it will behave. Okay, this is for finite element analysis. Okay, for CFD, actually, we are dealing with fluids. Actually, we have two different types of fluids. We have gas fluid and liquid fluid. Okay, so something like this car here, we're testing the gas fluid. Okay, because the gas here is the air. You're testing the resistance of the air on the geometry of the model you developed. This is one of the analyses of the CFD analysis type here. Okay. So before we start SolidWorks, we have to identify some crucial abbreviations here. We have something called CAD, CAM, CIM, CAE, and PLM. Okay. So again, CAD stands for or is representing computer-aided design. Okay, and we have to differentiate between CAD here and AutoCAD. Why? Because in AutoCAD, as I said, we're not doing design. It's not auto computer-aided design. Actually, when you're using AutoCAD, the application for 2D drawing, actually, this is called computer-aided drafting or drawing. So AutoCAD stands for Auto Computer-Aided Drawing or Drafting. It's not Auto Computer-Aided Design, okay? Because using AutoCAD, you're not doing any type of analysis. You're just doing 2D models, okay? So this is the abbreviation for CAD in AutoCAD. But actually here in product design applications and different packages here, we're talking about computer-aided design because most common packages we are using in product development or product lifecycle management here are doing something called analysis. You're not just doing a model, you're doing something using different types of analysis here, okay? Moving to the second one, which is computer-aided manufacturing. Actually, this abbreviation is related to something called CNC. CNC stands for Computer Numerical Control Machines. The machines or the manufacturing machines are dealing with computer programs, okay? So we have a CAD model or a CAD file, okay? And then you're translating this CAD file into something related or something like a code. So this CNC machine can translate this code and do the manufacturing process of this component. This is called the CAM process, computer-aided manufacturing process, okay? Moving to the second one, which is CIM, computer integrated manufacturing. Actually, if you have something called work cell, which is consisting of different types of machines. So let's say that you have a component and this component will be done using a series or different types of machines. So you have to have something like integrated machining or integrated manufacturing system. So this is computer integrated manufacturing. So it deals with different processes and different machines for a single component, okay? When we're talking about K, which is computer aided engineering, we are talking about the packages or the software related to analysis, okay? So something like ANSYS, Abacus, these types of applications, these types of software packages are just doing analysis, okay? So K stands for computer aided engineering, okay? And we have different packages, as I said, ANSYS, Abacus, and so on. The rest are doing this K process, computer aided engineering process, which is related to analysis, okay? And honestly, some different CAD applications like SolidWorks, Fusion, NX, and so on, the rest are doing the K process as well. But actually, they are not focusing in the K application, okay? Just 1 second here. Okay. Okay. Something like AutoCAD, something like SolidWorks. Okay. SolidWorks is dealing with CAD and K. Okay. Because you can do some analysis using SolidWorks, but actually SolidWorks is focusing in the modeling application and the modeling focus. Okay. So we are using SolidWorks something specifically for CAD, for computer-aided design here, okay? Finally, we have something called PLM. which is product life management solution. It's the full integrated solution of any product, including everything related to this component or this product. Okay, so this is very important. We have different packages of PLM packages. Okay, we have CAD and CAM and K and CIM applications. So you have to differentiate the concept you are using the application for. Okay, this is very important here. Okay, moving to the competition map. Actually, when we say the competition map here, we're talking about the programs or the applications related to product design or product development. Okay, so here we have some different competitors. We have the Systems, which is most common famous French company here. They're developing different types of applications. And we have Autodesk, which is one of the most other famous companies here. They're developing a bunch of applications. Actually, most Autodesk applications is not related to product design, something like 3D Max, something like Maya. These applications are related to, let's say, some artistic applications, okay? And we have this well-known company, which is Siemens. And finally, we have PTC, which is Parametric Technology Corporation here, which is one of the most, actually, the last one here is the father, or let's say, the beginner of CAD applications, okay? They started like around 1983, something like that. They developed the first CAD application, which was Pro Engineer. Okay, so they are considered the fathers of CAD applications, PTC, Parametric Technology Corporation. Okay, so for the SO, we have two different common applications. We have CATIA and we have SolidWorks. Actually, CATIA is considered as one of PLM solutions. Okay, so inside CATIA, you can do a CAD, you can do a CAM, you can do advanced modeling features, something like ergonomics, something like mockups, something like they have a lot of a bunch of modules and add-ons in CATIA. The most famous module in CATIA, which is ergonomics, because they have some different advanced features, something like rule assessment. When we talk about ergonomics, let me give a brief example about ergonomics. We are talking about human factors and human builders. So let's say that you're an operator in a specific factory, okay? And you're doing something like a repetitive task in a specific machine. So you have to assess, to do some assessment about your muscles, your, let's say your bones, your human posture. So you can do that using ergonomic size. So CATIA, and we'll talk about Creo and Siemens NX. They have, let's say, advanced ergonomics modules, advanced ergonomics, let's say, features, okay? So they're considered as PLM solutions, product lifecycle management solutions, okay? But when we're talking about SolidWorks, we're talking about CAD, CAM, and K solution or platform. So computer-aided design, computer-aided engineering, and computer, let's say, computer-aided manufacturing. So you can add some manufacturing modules or something like add-ons, okay, and SolidWorks to do the manufacturing process and generate the different types of codes to be manufactured using different CNC machines, okay? Moving to the second one, actually, we have a big list of applications and products in Autodesk, but the most two famous ones here are Autodesk Fusion 360 and Autodesk Inventor, okay? So Inventor is like a new application. It's around 5 to 6 years old application, but they are going to the market very fast. Okay, they are growing. Let's say they are developing more advanced features. They are targeting to be a PLM platform, but they can be considered yet or now something around CAD and CAM and K application. They are not touching the PLM platform or the PLM level, okay? Moving to the Siemens, actually we have different applications or platforms in Siemens. The most famous one, which is Siemens NX, okay? Actually, Siemens brought this application from something called Unigraphics, okay? So Unigraphics was like one of the top PLM solutions before, and Siemens brought this UGS or Unigraphics application, and they changed the name of this application to be Siemens NX, and they were in the top of the CAD applications for around 5 years, and now they are declining very fast. I'm not sure why, but it's like R&D process and R&D strategies inside each company here. Okay. When we talk about PTC, Parametric Technology Corporation, we have different applications. We have one of the top applications, or from my point of view, it's it's now the top application here, which is Creo. Creo is the development or the newer version of Pro Engineer. Okay, it's like the first application in reverse engineering and surface modeling. Okay, so if you have any product related to surface modeling or surface modeling applications, you have to use this application, which is Creo, because they have a smart, intelligent more advanced surface modeling features here inside this application. And they have one of the wonderful SaaS applications or platforms, which is Onshape. Onshape is like software as a service, okay, application. So you can use and manipulate if you have a pen in your device, if you're using, let's say, if you're using iPad or any laptop has something like a pen, you can use this application very, very sleek or very, very fluent or flexible. It's very flexible application. Okay, this application, it's around like, let's say 3 to 4 years. It's a newer application as well. And they have more advanced features. So they are competing Autodesk Fusion and SolidWorks. It's in the same level of this type of competition. Okay, actually we have like tons of different applications here, but these are the most common ones here. Okay, these are the most common platforms or companies, developers, and these are the most common applications for each developer here. Okay, so why we're using SolidWorks? We are using SolidWorks because it's most common CAD platform. In SolidWorks, there is the statistics say that the users of SolidWorks are around, I'm not sure, 47% of CAD applications. Okay, so around 47% of CAD users are using SolidWorks. So it's a very common CAD application or CAD platform. So if you develop any product using SolidWorks, you can share it with anyone very without any constraints. So it's very simple to share it with anyone. Okay, and again, in SolidWorks, its interface is very simple. That means that it's very simple to learn, very easy to learn. Okay, so its graphical user interface is very simple, easy to learn. Okay, and finally, it's compatible with different add-ins. So in SolidWorks, we have different add-ins or specific modules that could be added into SolidWorks interface. Okay, let's say that if you want to add the rendering application, we'll talk about rendering later in this presentation. Okay, so if you want to integrate some rendering features or some like rendering add-ins, you can integrate it with SolidWorks. Same if you have something like MetCalc or MIT Calc application. It's like an Excel sheet. You can develop any let's say standard component, something like gears, shafts, keys, something like that. You can just write some numbers in using Excel sheet. And once you're done, the part will be, the standard part will be generated in SolidWorks. So the compatibility with different add-ins is very simple here using SolidWorks. So it's very, very compatible with different add-ins applications. So this is why SolidWorks is very important, okay? In SolidWorks, we have major modules here. We can do something like a single part or single component. We can do a mechanical assembly, so or a rigid assembly. So let's say that if you have a product, and this product you have some functions, you have different mechanisms inside this product. So you can develop the interaction between different components here to develop an assembly of the product you want, okay? This is very, very important. So in SolidWorks assembly module, we have something called mates. Inside this mate feature, you can do something called the standard mate, advanced mate, and mechanical mates. So if you want to simulate or animate something like gear motion or screw motion, you can do it easily using this module or the mate in this assembly module here, okay? Moving to the last one, which is drawing, which is one of the most simple drawing modules in different CAD application here. Inside this module, major module in SolidWorks, the drawing one, you can draw anything from scratch as AutoCAD exactly, and you can project either the part or the assembly projected views inside this module, the drawing one. So let's say that you developed a 3D model of a single component or a 3D model of an assembly of a product, okay? And you want to take some projections or some cross sections of these developed 3D models, either this is a component or assembly. You can drag it inside this module and you can project whatever you want and develop either the working drawing or the assembly drawing, as I said before. So this is very fantastic feature here or module here. Beside those ones here, we have different minor modules. We have plastic design, electrical design, wires and harnesses design, welding and sheet metal design, tubes, pipes. These are like a specific design modules, okay, for each track, like electrical, welding, sheet metal. And actually we have another one for mold design, which is related to plastic products or plastic injections. So it's different than plastic design here. Okay, so don't mix between plastic design and mold design module here and the minor module as a minor modules here in SolidWorks. Okay. Actually, SolidWorks has different portfolios here. So SolidWorks can do 3D CAD. SolidWorks can do electrical CAD, something called ECAD. ECAD, which is standing for electrical computer-aided design process. And SolidWorks can do PCBs, printed circuit boards, simulation, visualize, which is one of the most fantastic applications in rendering, okay? So inside SolidWorks, there is an add-in feature, which is called 360 photo view. In SolidWorks, you can do some rendered photos. Rendering, which means, actually, it will be in the following slide, you're converting the cartoony profile of the model you did using any CAD application to something very real or close to the real photo of the product you want to do. Okay, so it's just trying to realize the pictures or the looking of the objects you're designing using different applications. So SolidWorks Visualize is one of the most fantastic rendering applications here, which is integrated directly with SolidWorks CAD files. And we have SolidWorks PDM, Product Data Management, and Composer to do something like different animations and different simulations and something like rendered, animated, let's say shots, something like that, okay? So in SolidWorks, as I said, we have rendering feature. So the one on the right, which is the real photo, this is the real photo of the application of this product. And the one on the left, on the most left, is the output of the SolidWorks. Let me try to annotate that. Okay, here. So this one is the output of the SolidWorks, and that one is the output of the rendering inside SolidWorks. So this is this rendering application, or this rendering process was done with the photo view 360, and which is integrated with SolidWorks. Okay, so this is very, very fantastic clocking here. You can do something like lightings, wherever you will put your camera in, to do some different perspective views of the parts you want here. So it's very, very fantastic application here, the rendering application. Actually, rendering is considered as a separate job. So it's like a profession, a separate or individual profession. Okay, so there is some guys are called render guys. So they are not developing CAD applications or CAD files. They are just doing rendering for these CAD applications. Okay, so it's a marvelous track and completely different track than CAD. Okay, so don't mix between rendering and CAD. Actually, rendering is based on CAD. Okay, but it's completely different process. Okay, so let's stop this annotation. Okay, so again here, SolidWorks, let's go design. Okay, so let me stop this presentation now and let me open the interface of SolidWorks, and let's have like a fast preview or fast logging on the interface of SolidWorks. Okay. Okay. So now, can you see my screen? Slam, are you there?
Yes, we can see it.
Yeah, sure. Okay. Okay. So first of all, when you double click on the SolidWorks, after installing the SolidWorks application here, when you double click on the icon of SolidWorks, this will be the starting interface of SolidWorks. Okay, so we have different buttons here, and we have different menus right there. So if you click on this new icon here, you will create a new document here. If you have an existing file you want to open, you can open it from there. Okay, so let's start with this one. So when you click on new document here, okay, you will find that you can do a part, you can do assembly, you can do something like a separate drawing. So let's start with the part one here, the part module here. So once you hit OK, if you are opening SolidWorks for the first time, it will ask you to select the standard and the units, which will be fixed later when you open SolidWorks every time. So to convert or to change the units here, you can change it from there, from this down corner menu here. So here you can change it from millimeter gram second to centimeters to meters to inch pound and second, whatever you want, you can change it from there. Okay, but because I opened SolidWorks for like many times, so I don't have this start window which is appearing for just the first time. Okay, so this is the interface or the start interface of SolidWorks using the port menu. Okay, actually it's very common interface, like different office applications like CAD, PowerPoint, Excel. We have something called here ribbons or tabs. So we have feature ribbon here, and we have sketch ribbon, surface, sheet metal, and blah, blah, the rest here. Inside each ribbon, we have different sections. Okay, so we have here a section right there. We have another section here. We have, and so on, the rest, different sections. Inside each section, we have something called features. Okay, so this is considered as a feature, extruded base or boss here, revolved boss or base here. This is a separate feature, okay? So again, we have ribbons or tabs, then sections, then features inside each one, okay? Actually, if you want to eliminate the tabs or the features here or the ribbons here you are not using, you can right click at any one, and here from tabs, you can select or deselect whatever the tab or the ribbon you want. So here, if you're not using, let's say, MBD dimensions, you can untick this one and it will be disappearing from this ribbon here. Again, whatever you want, you can deselect or select the ribbon you want from there. Okay. So if you will open this application for the first time, you will not seeing those much tabs here. You will see like features or sketch or many different little number of tabs or ribbons right there. Okay. Okay, perfect. So as I said, this is like the tabs area, or let's say the ribbon area here. And in the middle right there, it's like a working or drawing or modeling areas here in the middle, which is gradient color was gray. You can change this color. Actually, I prefer to make it plain white here, but if you want a 3-point faded background, you can change it from there, from this background here. And actually, if you want to set something like, let's say, environment or scene, or something like a different asset or different scene or environment, you can do something like that. And you can integrate whatever you want from different, you can manage the favorite assets or 360 photos or environments, you can integrate it here, okay? So let's move back to the default interface here, which is this one here. On the left, right there, we have very important section here. So right there, we have feature manager design tree. So whatever step you will do for each component, it will be shown in this area. Okay, so now we don't have any features right there, right? So once we start doing anything, they will be recorded downside right there. Okay, these are the steps, or the, let's say, the features will be created once you want to develop anything here. Okay, so let's say that we want to develop something like a cube or something like a cuboid profile. Okay, so first of all, we have to draw the 2D profile of this cube. Then we have to make the extrusion or take a section, or let's say a thickness of this profile, okay? Okay, so again, let's assume that we want to develop a cube here. So let me select this rectangle feature, okay? Then it will ask me to select which plane I want to start the sketch in. So let's say I will pick this front plane here. So here will be the x-axis and the y-axis of this plane as shown here on the downside here. So if I want to make this plane to be perpendicular on the screen here, I can, from this icon here, I can click on normal to or control 8. Okay, so if I click here, control 8 or normal to, these two axes will be perpendicular on the screen. So now I can draw 2D profile right there. Okay, so let me start to draw something like this rectangle right there. Actually, I can change the dimensions of this rectangle. So I can hit here, smart dimension, click any line I want. Okay, write the value. Let's say that this line length will be 100. Okay, and that one will be, let's say, 80 millimeters. So now I have a rectangle. This rectangle, I can change these dimensions later. So if I double click on this 100, I can change it to be 120 millimeters. And this one, let's say it will be 90 millimeters. So you can change the dimensions. So this is a 2D profile, okay? So I am now in the sketch interface. I did a rectangle, a 2D rectangle profile. So if I want to convert this rectangle to be something like a 3D, so I have to put the third length of this 2D profile, okay? Let's say that I want to make, to add a thickness for this 2D profile. So now I can go to features, then I will extrude a length or extrude a thickness of this 2D profile. So if I click there, okay, so now it will ask me how many millimeters you want to add as a thickness for this 2D profile here. So you can change it from here. So let's say that this one will be 75, okay? You can click on this icon right there. So now I have a 3D profile. I can manipulate it by just click on this on the scroll button here in the using the mouse. So using any CAD application, you have to, or you are highly recommended to use a mouse, a separate mouse. Don't use your keyboard mouse pad, because there is different functions of the scroll button in the mouse. So let's say that if you want to zoom in and zoom out, so you can do that with the scroll. If you hold the press on the scroll, you can rotate the 3D model as you can see right now. Okay, so this is very important. You have to have a mouse while you're doing any design. Actually, this is not in using SolidWorks. Actually, any CAD application, you have to have a separate mouse, okay? This is very recommended, or highly recommended, okay? So now, here in the left, I have a new feature here, which boss extrude number 1. You can double click and name it, whatever the name you want here. Okay, so let's say this is maybe something like thickness. Okay, or thickness 1, whatever. Okay, so you can double check and change the feature name here. This is called the feature. Okay, so to master this simple application, this SolidWorks application, the key is just differentiating between the feature interface and the sketch interface. Okay, this is like a nutshell the SolidWorks. If you are using SolidWorks for the first time, or you are not familiar with this application, to master this application, you have to differentiate between the feature interface and the sketch interface. Okay, so how can we do that? Actually, when I did this keyboard profile, first of all, I did a sketch, a 2D profile. So I went to this ribbon, then select that one, and then selected it. Asked the application asked me to select which plane I should select. Then I start sketching the profile I want, right? So this is the first step. Then I went to this feature ribbon, then selected this one. This is called extruded boss, and then I added a thickness to that profile. Then finally I have this cube here, right? So we'll do it again, okay? But actually here, if I want to change or edit any dimensions here, so here I have 3 dimensions. I have a length, a height, and the width here, or the thickness right there, okay? So how did I do that? Actually, I made a sketch, as I said, and then I added extrusion value of this sketch here. So if I right click on this feature here I have 2 different options. The first one, which is edit feature, and the second one, which is edit sketch. Okay, so if I click on that one, edit feature here, it will ask me to change the thickness value. So I can change the 75 or the extrusion value right there. Okay, this is the first step. Okay, this is this is the second step. Okay, so if you click OK, then you will go back to the feature interface. But actually, if I right click again and click on the second one, which is edit sketch right there, it will turn me back to the initial sketch interface. Okay, so if I click here and click normal 2 or control 8, okay, now I'm in the sketch interface. How can I know that I'm in the sketch interface? When I can see those ones here activated, that means that I'm in the sketch interface. That means that all features in the sketch ribbon are highlighted here. They're not dimmed here. They are all activated right there. Okay, that means that here I'm in the sketch interface. Okay, so now I can double click on that one here. Let's make it 140, hit OK. Let's change that to be 100, hit OK. And now I change it, those two dimensions. If I want to come back or turn back to the feature interface, I will just click on this exit sketch icon right there in the right here. Okay, so now I'm back into the feature interface. So again, you have to differentiate between the sketch interface and the feature interface. If you did that, honestly, everything in this application will be very, very simple there. Okay. Let's say that we want to start another feature. So let's say that we want to make something like a hole or a cut on that face. Okay. So here I will select this face here. Here I can find that I have this rectangle right there. Here I can edit the feature, edit the sketch, and start new sketch right there. If I click on that one here, which is start new sketch here, now I'm now in the sketch interface. So if I click on normal 2, I can draw whatever I want here. So let's do something like random profile right there. Okay. And now I have a closed profile using different lines right there. If I go to this feature ribbon, here I can find that I can find the feature that called extruded cut right there. If I click on that one here, I can cut through this thickness here. So these are the thicknesses or the cutting depth I want. If you want to cut through all, you can select from this menu through all feature or through all option right there. Okay, so if you want to make like a specific cut with different with a specific value, you can click here. Okay, so now this cut is not to the end. Okay, if you want to make it through all, you can edit the feature and then change the option right there to be through all and then hit OK. So now we can see the other side, which is white right there. Okay, so this is the extrude cut feature right there. Okay, here I can manipulate different views or different style views of this 3D model right there. So if I click here in this style preview here, this one is shaded with edges, this one is shaded only. So now I can see the edges right there. If I click on that one, I will have something like that. Okay, so this will show me the hidden details or the hidden edges. Okay, and here I can find something like that, which is wireframe. It's very, very ambiguous. So the wireframe modeling or 3D modeling is important, very important in specific tracks. Actually, in harnesses and wires and pipelines, in this sector, actually, the wireframe, the 3D wireframe modeling process is very, very crucial in different types of applications. Okay, so for the simple 3D model of any product, it's ambiguous. So if you have something like that, you don't or you can't imagine which is the in front of each one. Okay, it's ambiguous. It's not clear. Okay, so this is the wireframe modeling. Okay, and actually, if you want to add like something like add the camera or render style here, you can do that here. but actually this is the default one here, which is shaded with ages. So this is giving you like let's say a feeling, a solid feeling of the part you're developing or you're designing here. Okay, so let's move to the feature tree here. So now to do this object or this component, first of all, I did a sketch, then I made a thickness. I did extrusion value for this sketch. Then I have this cuboid profile. Then I started new sketch on top of this face. Then I extruded cut this profile. And actually I can edit either the sketch profile here. Okay, you can edit the sketch profile, then click on that one here. And you can edit the extrusion value, the cutting value here. Okay, so if you want to make it with the specific cut, you can change it right there. Okay, so in SolidWorks, you can, the good news that you can actually, in all applications, you can change whatever you did, okay, while you are designing or you are modeling the components or the assembly or the products you want, okay? This is the good news. Okay, so let's move back here and let's start another port again. Okay, and let's do something like random sketch. So I will select a line, then I will select this front plane. Okay, then click normal to. Okay, and then let me start something like square, something like that. Okay, here I have blue lines and black lines here, there, right? And downside there, I can see that this profile is underdefined. It's not a fully defined sketch. This is very, very crucial in 3D sketching or in sketching interface in SolidWorks. So that means that everything you are sketching in the sketch interface in SolidWorks should be fully defined. Defined for what? Defined to what? To this origin, okay? So whatever you're drawing, it should be defined to that origin. So if I put the dimension right there, let's say that this one will be 50 millimeters. And let's say that this height will be 70 millimeters. So now I have all black lines right there. And downside there, I have a fully defined sketch. That means that everything, every entity, every element I did in this sketch interface is defined to this origin point. And this is very crucial. Why this is very important? Because let's say that you have a complex component, and this component you will do something like around like 50 features, 50 number of features, okay? And if the first sketch and the first feature is not defined to the origin point, and you want to change or modify, let's say, the feature number 26, okay? Once you change the dimension of the sketch in the feature number 26, okay, everything will be damaged, you will have like a lot of number of errors because the first one is not defined to the origin point, okay? This is very, very crucial. Everything you will do in the sketch interface, it should be defined, fully defined to this origin point, okay? This is to avoid any further mistakes or problems while you are editing any later features, okay? This is very important, okay? So if you want to draw, if you want to do something like this rectangle here, we can activate here a corner rectangle, okay? And then you can put the dimensions, okay? Let's say that if you start a rectangle from any point to other point, and if I put the dimension here, let's say that this will be 70 millimeters and that one will be 50 millimeters, okay? So now I added those two dimensions to this rectangle, and this rectangle is still underdefined. Why? Because those edges are not defined to the origin point. So I should define those ones to the origin point. So let's say that that one will be 45 here. And this length will be, let's say, 40 millimeters. So now I have a fully defined sketch. And instead of doing that much steps here, we can use something called center rectangle. So if I click on center rectangle, and if I started from the origin point itself and open up something like that, and then if I added the dimension to that one here and change the dimension here there, okay, now I have a fully defined sketch. Okay, that's very, very fantastic feature. If you started the rectangle using the center point rectangle, you will avoid adding more dimensions to define this rectangle to the origin point. Okay, and then you can go to the feature ribbon, add the extrusion value, and confirm with the thickness you want. Okay, so let's have further details here. If we go further to that section here, we have something called here fillet. Inside this one, we have chamfer. Okay, so let's click on this fillet icon right there. Okay, and let's say that we want to select this edge right there. So if I selected this edge, it will give me like a rounded corner right there. I can add the thickness I want, or sorry, the radius. I can define the radius value of this fillet feature. And now I can have something like that. Okay, so let's say if I edited this sketch right there, so now the feature of the fillet disappeared. Why? Because this feature is based on that feature. Okay, so this one is made after that one. So this is why I can't see the fillet feature right there. So let's say that I want to add another feature here or fillet right there. So in the sketch interface, I can do a fillet as well. So if I click on that one here and click on this point right there, I can add or increase the radius of that fillet, and then I can, okay. Okay, if I click on this exit sketch feature, I can find something like that. Okay, that means that I can do this feature using a sketch interface or a solid interface or feature interface. Okay, but if I did it using the sketch interface, it will be integrated inside this one. So if I open up or maximize this or expand this feature here, I can see that this one is dependent or the child or like a child of that feature. Okay, so this extruded bus feature is based on that sketch. Okay, but this one is a standalone feature, the fillet one here, which I did on that corner. Okay, this is for the fillet. Okay, so I can use this one or this feature either in the solid interface or feature interface or the sketch interface. Okay, let's move to another fantastic part here. If I click a new part right there, let's say that inside I will go to sketch interface here, the sketch ribbon, sorry, here, and under the line menu, I will select the center line, select the front plane, make it normal too. Then from this origin point, I will go up, something like that. Okay. And let's draw something like a vague curve, something like that. Okay, let's change it. Something like that. Okay. Now, if I go to feature ribbon right there, click on this revolve one, it will ask me, now I have a center line, so I want to make a revolution around this center line, yes. So I will have something like that. Okay, so now this center line will be the axis of revolution, and the angle or the direction of revolution will be 360. You can decrease this one let's say if you want to make it 270, whatever the rotational direction or the angle you want, you can add it from here, and then you can hit OK. So now I have something like that. Okay, you can take a cross section to show the cross section of that random or vague geometry I did right now. Okay, I can manipulate the angle. Okay, I can just do something like whatever I want. I can add more sections right there here if you want to do something like different sections view. So you can activate it from here, hit OK or not, something like that. Okay. Okay. So in the feature interface or the feature ribbon or tab here, I have like let's say I'm not sure if you know the Boolean operations like union, subtraction, and intersection. Here I have like adding features. So this is extruded boss, this is revolved boss, sweep, loft, boundary boss, and these are the negative features. So you can consider that those sections, those features in that section are the opposite of those features in that section, or the negative ones of that one. So here I have extruded boss, here I have extruded cut, here I have revolved boss, there I have revolved cut, and so on the rest. Okay, so you can add the negative feature or the reverse feature using those ones here. Okay, let's move further. Okay, so let's assume that I have a route or a path. Okay, so let me open up a new part here. Okay, so let's say that I have a line right there. Let's make it perpendicular to the screen. Okay, go here and there, something like that. We can add rounded corners here and there, increase the values right there, and then hit OK. Okay, and then again, hit exit sketch. So now this one will be gray. If you want to edit this sketch, you can double click on it, and now you will be turned to the sketch interface. If you want to close it, you can do it from there. Okay, so now I can't edit this sketch while it's in gray locking right there, like that one here, because I'm not now in the sketch interface. So I couldn't change any dimensions of any of those lines here. Why? Because I'm now in the feature interface. I can't see the exit sketch option right there. So if I double click here, or from there, if I edit the sketch right there, so now I'm in the sketch interface, so I can change or manipulate the values I want here. Okay, so let's select another plane. So let's say that we have a right plane right there, and I want to draw another thing on that plane here. So if I click on this sketch here, so let's assume that I want to draw something like a circle right there. Let's add a dimension. So if I click on the smart dimension right there, I can click on any point on that circle and change the dimension and then close it. So now I have two different sketches here, two different profiles right there. One is the path and one is the profile. So I want to project that profile into that path. How can I do that? From features, swift path here. So here I have the profile and there I have the path. Okay, so in the profile, I will select this circle, and the path, I will select this line. So I will have something like that. Okay, this is the swept both feature here. Okay, actually we can manipulate something very interesting. Let me show you if you want to do something like a bracelet, something related to jewelry in industry. So let's say that I have I will draw a circle on the top plane, something like that. Let's assume that this circle dimension is 100. Actually, I have a very fantastic shortcut right there. If you hold the press on the right click, you can find that wheel. So this is like a fast shortcuts here. So if you hold the press on the right click using your mouse, okay, you can find this wheel and you can actually change those features or add more shortcuts here. So if I go up, I will automatically select the smart dimension. If I go to the right, I will start circle feature. Go to the left, I will select a line, and go down, select a corner rectangle, okay? So these are like fast shortcuts using the mouse gestures or your mouse shortcuts, okay? So now I will exit the sketch here. And on, let's say on the front plane, okay, I will start new sketch. Okay. Let's say that I will draw something like an oval, something like that. Okay, let's increase it a little bit. Okay. And then hit exit. So now I have a circle and another oval on the path of this circle, okay? So if I go to features, go to swipe boss, here I will select this as a profile and that circle as a path, okay? So I can find that I can do something like this bracelet right there, okay? Or this donut, okay? I can manipulate this profile right there. So here I have some different options here. So I can make something like twisting here. So I can add some different twists right there. So I may have something like that. Very interesting. Okay. So this is using the swept feature right there. Okay. Moving to the loft feature. Okay. So using the loft feature, I can match different profiles together in different planes. Let me show you how can we do that. So let's assume that we have a rectangle right there on this plane. Let's exit the sketch. This one, we did it in the top plane. So let's create another plane. So if I select features from reference geometry here, I can select another plane, then go up with the thickness I want right there, hit OK. And then on this plane, I will start new section or new drawing. So let's say that I will draw another circle right there, something like that. Okay. So now I have two different profiles in two different planes, and I want to match between them. I can do that using the loft boss feature right there. So here, if I selected this sketch, and there, if I selected that one, it will be matched together, okay? So using those two green dots right there, I can manipulate the twisting between those two profiles right there, something like that, okay? And again, if I have two different profiles, so let's say that I will draw another profile on top of that one. So let's say that I have a small circle right there. Exit sketch. Let's do another larger one on the bottom side right there. Okay. So that circle will be on the lower side. Sorry, again, it's not on the lower side. So I will exit the sketch and select this face, start new circle, make it normal too. So now I'm on the bottom side. So here on the top side, I have a smaller circle. On the bottom side, I have a larger circle. So if I selected this lofted cut feature, selected this one right there and selected that one here, it will cut through them. If I take a cross section, I can see that I have a slope right there. Okay. Very interesting. Okay. So this is how can we manipulate different features right there. Okay, and I'm not sure if you're getting bored right now or should we continue. Actually, in SolidWorks, we have a lot of secrets. We have like tons of secrets and many different features. I'm not sure if you want to continue to give you a brief about assembly interface or not. So let me open up the assembly interface. So here in the assembly interface, actually this is a ready-made one. So let me open this component or this assembly. It's like a mechanical jig right there. So in the assembly interface, the way is different. The ribbons are different here. So here I have assembly ribbon, okay, which is like 90% of applications or features you will do in the assembly interface, you will be using that ribbon, okay? So if you want to insert another different components, you can just click on that one here and browse wherever the component directory in your machine is, and then select it, and then it will be inserted right there. So let me show you how can we do that. So if I click on that one here, it will insert that one right there. You can change or manipulate the assembly direction, okay, of this component, okay, wherever you want to locate it. Okay, you can change it later, by the way. So if I click on this component right there, from move component, I can rotate it wherever I want, okay? Beside this insert components feature, I have something very interesting, which is mate feature right there. Inside this mate feature, okay, I have different ribbons or different types of mates here. I have something called standard mate, mechanical mate, an advanced mate, and analysis mate. Okay, this is not a mate. This is like a motion analysis feature here. So here we have those three ones here: standard, advanced, and mechanical mates. Okay, using mechanical mates, I can do something like a cam profile. So in the mechanical cams, okay, we can have two different cam elements. The cam elements are the cam profile itself and the follower. Okay, so the follower is just following the cam profile. So if you want to simulate or if you want to join two components as cam and its cam follower, you can use that mate type right there. And here if we have like a slot slider system here, and hinge, gears, rack and pinion, screw, and universal joints, you can use those different mechanical mates. And the standard mates, it's like fixed or rigid mate features here. So the first one is coincident. That means that if you select any two different faces or face and line or face and point or whatever, we have three main elements: face, point, and edge. Okay, if you select each two types of any ones, they will be coincident together. I mean that they will be stuck as one rigid component. It's some sort of welding, but it's not a welding feature. Okay. From its name, the parallel, that if I selected two different faces, it will make them parallel together, perpendicular as well, tangent and concentric, that used for cylindrical features. So if I have two different cylindrical features, either shaft and hole, I can allocate them together. So let's assume that I will select this cylindrical feature, okay? And without being selected, this one here, if I selected this hole, okay, they will be automatically concentric together, okay? Something like that, okay? So this is like a smart feature, smart mate feature here, because the software detected that those are two different cylindrical features and they should be aligned together using the same center axis of each cylindrical feature. So that is why this one is automatically selected, okay? These are the different types of mate. Once you're done with the mates here, you can add different motions or different, let's say here, exploded views. If you want to animate some different motions, something like that, you can animate them from here, okay? You can insert some motors here. Either this motor is rotary and linear motor, you can add them, and then you can animate whatever you want, okay? And the good news here in the assembly interface in SolidWorks, that we have something very interesting called a toolbox. That means that you can insert or add any standard component using this toolbox. How can we find that? From here, I have something called design library right there. If I click on that one, then I will find that I have a toolbox option right there. If I click on that one, I will add and now, then it will show me the different standards. So mainly we're using ISO standard. If I click on that one, I can select or add or insert into the assembly interface either bearings, bolts and nuts, keys, nuts, O-rings, bends, whatever. If I have different gears right there, whatever I want from those standard components, you can add it. Just drag that one here. If I drag this one here, it will ask me about the options or the different standard size here. So here I have select the metric type or the metric size of this bolt. Okay, so let's say that that one will be 10, and it will give me the different range or the interval range, standard range of this M10. So because this is a standard component, so when I selected M10, it will be automatically detected that every standard bolt M10 size will be ranged in length between 12 and 60. Okay, it couldn't be lower than 12 and it couldn't exceed 60 millimeters in length. Okay, and you can add the thread length if you want, if it's completed through all or not. And here is the profile, either cosmetic preview or schematic preview, something like that, or simplified without showing the texture of the thread. So this is how to add standard components, okay? This is like the assembly interface in a nutshell. Let's move to the drawing module here. For the drawing module, once you started the drawing module, it will ask you to select the standard size of the sheet you want to be using in the drawing module. So if you are using A3 or A4 formats, ISO format, you can click. Okay, so now you have this interface. Okay, so this is the standard A3 sheet size, ISO size. Okay, so from the drawing ribbon right there, you can add the model, browse whatever you want here. So let's add this part right there. And once you clicked here, it will give me the different views or the different projected views of this part right there. Okay, and actually you can change the style or the preview style of those ones here, even hidden with edges, with hidden details. Okay, you can change the scale of those ones here. Okay, if you want to make if you want to make them 1:1 or whatever the scale you want here. And then if you want to make a cross section, let's say that I want to make a cross section in the middle part of that one here. So it will give me something like that. Okay, and these are the different types of views, either broken out section, a section view, auxiliary, or the projected view, or detailed view. So let's say that I have a small detail here I want to show in a separate view. So it will take like a snapshot of that one here and put it right there, something like that, okay? So this is the drawing module here. So this is the case if I have a part or an assembly and I want to project it in the drawing module. So if we deleted everything right there, okay, I can start sketching whatever I want from scratch here. Something like using AutoCAD, okay? And you can change the dimensions. If you want to add texting from annotation, you can add text right there, and do whatever you want, something like AutoCAD interface, 2D pure drafting. Okay, you can do that. Okay, so what if you want to change the details of this title block. How can we do that? From this ribbon, which is sheet format, if I click on that one, and then from edit sheet format right there, I can change and manipulate the details on this title block. Okay, so if I click on that one to go back to the sketch I drew, this one is like a watermark. I can't change anything of this title block. I can select it, even select this one. But if I go to sheet format and click on edit sheet format, now I can manipulate everything. Can change whatever I want. Either you can delete or add texting, whatever you want. So let's say that I will add a watermark here or something like Ahmed Hamdy here. And if I click on that, Ahmed Hamdy right there, it will not be selected because it will be considered as a watermark because it's a part of the title of the sheet format. Okay. So this is the difference between this and that. Here, this text or this note, I added in the drawing interface simply, but that one I added in the editing sheet format. So this one will not be selected. Okay, you can add the logo of your company or your university, whatever. If you want to add the projection style, if you're using third angle projection or first angle projection, okay, the symbols of those projection types, you can add them here, whatever you want. So this is simply the drawing interface in a nutshell. Okay. Islam, are you still there?
Yes.
I'm not sure if this is good for today or not.
We can ask the participants if they want more. يعني.
Yeah, if you have some questions, we can open up the discussions and questions. Okay.
Yes, I think it's a good idea to have like some time for Q&A.
Yeah, sure.
Okay, so if anyone has any questions, you can raise your hand and we'll answer your questions by order.
Guys, are you still with us? So let me ask you another question, guys. What's your opinion about this session? واسلام مفيش الا انا وانت بس ولا النت قطع؟
لا هما بيكتبوا في الشات اهو.
اوكي بيرفكت. اوكي.
We are glad that you liked the session. Would you like to have more sessions with the same type or with the same format?
I don't know. I don't have any problems if you want more sessions. Actually, I tried to give you like a brief introduction about the application, everything in nutshell, everything in the outer view. Actually, this is not the SolidWorks I gave you today. It's like the overview or like scratch. We touched the scratch of this application. So as I told you, this application has a lot of secrets, has a lot of marvelous features inside it, but we have to dig more. But this is you told me that this is like an introduction to SolidWorks, so it's like a brief introduction about the application. So guys, if you have any questions, you can ask it in the chat and I can answer any question.
And we will try to organize more sessions like this, and even we can get also instructors from the other universities, AUB and AUS, to make the process more collaborative. and for more people to participate. Yes, I think someone has a question. Is it Nafiz or Nafiz?
Nafis, can you hear me?
Yeah.
Yes, we can hear you.
Okay. So in our uni, we learned how to use Inventor. So we just want to ask, like, uh, how long does it take to transition from Inventor to SolidWorks?
Okay. Actually, if you want the same, actually every software or each CAD package has its own strategy or own building structure, but actually they are most common in the interface. So in Inventor, actually you have the negative features inside the main feature itself. Okay, so if you want to add or subtract a material from a solid body, you can add it from the same feature. Here is different. Okay, so the style is almost the same. The concept is almost the same, but if you have a solid base or a solid background in CAD or using CAD, it will be very simple to migrate to any different CAD applications. Okay, so they are like a family. Let me explain it. So some applications has the same concept of Inventor. So let's say Siemens NX have the same procedure of Inventor, but if you are using CATIA or Creo, the way is different. They are very close to SolidWorks interface. You got what I mean? But actually the concept is the same. You got it?
Yes. And also, what about compatibility issues?
This is a very good question. Actually, for each CAD application, we have something called N and N file formats. The first N is native, and the second N is native and what? A neutral. Sorry, native and neutral formats. Okay, so the neutral formats is like the different CAD formats. Let me show you. I'm not sure if I'm still showing my. I'm still sharing my screen, right? Let's say let's take this part as example. So if you click save as right there, if you open up save as types here, you have like tons of different CAD formats right there. So the SolidWorks assembly format is called a native format. This is a specific format for SolidWorks. Okay, but actually if you go down here, we can find that we can have something here called IGS or step or bar solid, step or bar solid. If this is called neutral format, okay? So you can save anything as native format like IGS or step or bar solid, and you can open it in different application. You got what I mean?
Yes. What I was more specifically asking was, like, within like, you know how SolidWorks, like how Inventor keeps updating itself every year, right?
Yeah.
So what I found was that if you model something using a newer version of Inventor, you can't use it with the older version. So does SolidWorks have the same problem?
Yes, honestly, yes. But actually in SolidWorks, we have workarounds processes. We can do that. We can do something called bar-solid conversion. So this is after deep investigation with me and my colleagues, we investigated the bar-solid file extension. Let's say that this version is 2022, okay, of SolidWorks. And I want to open up this assembly file using SolidWorks 2020. Okay, so it's like older was 2 versions. Okay, and if I try to open up this assembly file using SolidWorks native format, it will not be open in the older application or on the older version. Okay, so how can we manipulate that? We can save it as parasolid file, and then if you save anything as parasolid file, you can open up this file using older versions of the application, and it will be something like, let's say, automatic conversion or detection process of the features. You got what I mean? You got what I mean? and then it will be try to translate each feature which is done in the newer version and translate it to the older features in the older version. You got what I'm talking about?
So in this one, will it, we can still edit the features, right? Or will it become like a mesh file?
It will not be, you will have something like a solid base, okay? Solid base or solid body. And based on that file or this, sorry, this body, okay, it will detect or create different features, okay, later on this solid body based on that file or the conversion process. You got what I mean? So
yes, thank you so much.
You can edit it later.
So will we get the original features or can we add
Yes,
features?
Yes. Actually, the R&D guys in each CAD platform, let me show you something very interesting here. So I'm not sure if you can see my screen now. You can see it, right?
Yes.
Okay, I'm not sure if you are seeing my desktop or the SolidWorks. You can see my desktop or the SolidWorks.
Desktop.
Okay, so let me show you something very interesting. This is the R&D process of each application here. So this is another application which is called Creo. Here, if you open this file, you can open something called SolidWorks here. Let me show you here where SolidWorks. Yes, can you see that? Inventor part, SolidWorks assembly. Can you see that?
Yeah, can see that.
Yeah, this is what I'm talking about. I can't say that you can edit or not now because actually they are developing everything like every second. The R&D guys in each platform, in each CAD application, they're developing everything dramatically. So now today you can open up SolidWorks assembly file in different application without being converting the SolidWorks file to Parasolid or to the neutral format. Okay, you can open up this one here in different application, and then you got the wall features. You got it?
Yes. Will you be exploring the NURBS features later on?
The NURBS features actually, I recommend if you want a specific session or a specific, let's say, workshop or introductory session about reverse engineering, we can use Creo, because actually Creo, as I told you in the beginning, is the father of reverse engineering applications and platforms. NURBS feature is one of the smart features in surface modeling, and Creo is the top application in surface modeling. Yeah, honestly, okay. So if you want to use any product related to surface modeling, you have to, or you are highly recommended. Let's say you are highly recommended to use Creo. If you want to develop something, use assemble features, you can use SolidWorks because it's very simple and it could be migrated to different applications. Okay. And for sheet metal, for example, sheet metal, if you have something related to sheet metal, I completely recommend to use CATIA. So it depends on the application you are using or you are developing. You got what I mean? So each feature or each track or each industrial concept is related to a specific platform, which is highly recommended to be used. For me, if I have a freelancing job and this job is related to surface modeling, I'm using Creo. The same for sheet metal, I'm using CATIA. Anything related to direct features, I'm using SolidWorks because it's very simple and commonly used around the world. You got what I'm talking about? So it's like the application itself, which is drive me to use a specific platform. So if you want to take something related to surface modeling and NURBS, I completely recommend to use Creo. Really.
All right, I will look into. Thank you
Yeah.
so much.
You're welcome. Okay. Do we have any other questions, guys? Hello. Thank you, Kamil. Thank you all. Okay. So if you want a specific sessions about anything, I have no problem. We can organize it later. I'm very interested in additive manufacturing and reverse engineering and mold design and let's say jigs and fixtures. Okay, so whatever the field I'm interested in, I'm completely. It will be my pleasure to do sessions for you. Thank you. Thank you all.
We would like to thank you all for attending this session, and we hope that you liked it. And we'd like to also thank Engineer Ahmed Hamdy for his great effort.
Thank you.
It was a very informative session. I enjoyed it. And please stay tuned for more informative activities like this one, and we will try to make even more fun and informative activities in the coming period. So please stay tuned for this, and we will be communicating with you very soon, inshallah.
Thank you. Thank you all. Thank you all so much.
Thank you, guys. Thank you.
Thank you, Ramadan.
Thank you. And Ramadan Kareem, yes.
Okay.